Hello my dears. Today we are going to discuss about very important topic in power system, which is nothing but stability. Already we learned about stability in control system now. So there means, see, in electrical engineering, if you go deeper and deeper into the subject, you will feel that everything is same actually. No, there will not be any distinction between subjects. Clear? So the techniques which we already used in finding the stability of the system, it was using Laplace transform or any method for finding the stability, root locus or RH stability criteria or anything. So for all that, actually you can apply in power system, you can apply in signals, you can apply in machines, everything you can interconnect everything. So now we are going to discuss about the stability. It's very important topic actually, my dear. So first of all, what do you mean by stable or stable system? I will give you a small example. Okay, I will give you a small example. What is mean by a stable system? See, it's normally in from +1 +2 or after that, normally for explaining the stability, this diagram will be very helpful actually. See my dear, this is a ball actually, this is a ball, this is system 1 and this is system 2. See, if I introduce a small force here, what happened? The ball will move towards this direction, right? The ball will be like this, or in direction also the ball will be like this. If I apply any disturbance in both direction, the ball will temporarily move to another position, and after, if I remove that disturbance, what happened? The ball will come back to its original position. So such a type of system is said to be stable. See, but in the case of a next system, if I introduce any disturbance here, the ball will move down. Even if I removed my disturbance, the ball will not come back to its original position in either direction, in direction or that direction. This is an example of unstable system. Very simple example actually, very simple example. So what is meant by stable and unstable system in power system, like in control system also? Stability means nothing here. Even if you give some disturbance to the system, if after some time or even after the disturbance is not there, the system itself adjusts its parameter, or the system itself adjusts to itself, and after it comes back to the original position, then we can say that the system is stable. Otherwise the system is unstable. Listen my dear, so in this is general example actually. In the case of a power system, from where we get electrical energy, or the brain of the power system is nothing but the alternator. So this is my alternator, or synchronous generator, or simply alternator. Okay, that's fine. Alternator. Okay. And what is the input of the alternator, my dear? Input is nothing but, my dear, kinetic energy, right? We have to rotate the shaft of the alternator, then only the electrical energy will be produced. So the input is nothing but kinetic energy, which is nothing but half J into omega Sm squared. In terms of angular velocity omega and moment of inertia J, we can represent kinetic energy. Half mv square is nothing but for a linearly moving body, right? Linear motion. Half omega, that is half mv square. V is the linear velocity. In the case of rotating things, you have to use this half J omega Sm square as the kinetic energy. If we input to the machine is given by half J into omega square, what happened? The alternator will produce the electrical energy, right? Electrical energy as the output. So this is the what happens inside the alternator. We are giving some electrical energy and the output will be what? We are giving some mechanical energy, the output energy will be the electrical. So what happens, my dear, if I am increasing the speed? What happens if I am increasing the speed? Increase the speed means increasing this omega sm. What happened? See, the output electrical energy having a frequency f is equal to Pn by 120, or you can say that n is equal to what? 120 f by p. So if I am increasing my speed means in the output electrical energy it is reflected as increasing frequency, because p is constant and 120 is constant. So n increasing means correspondingly f will increase. We are using 50 Hz supply now. So increased frequency, is it tolerable? Is it advisable? No. So that is a type of disturbance. That is a type of disturbance. And one more. Suddenly a lightning occurs in the transmission line. Then alternator leave, but the transmission line, what happened? Suddenly a lightning happens. Again it introduces some voltages and it disturbs the overall system. So that is also a type of disturbance. And again, if the load will suddenly increases, what happened? The load will suddenly increases means this kinetic energy is not enough to supply the increased load demand. So at that time what will do? The load will absorb more and more current from the system, but the motor is not able to give that much current. So what will? The machine will be tired and the machine will say, Ayo, I don't have to give this much current to you. So what I don't want, means I'm so tired. So what happen if I am tired? What happen if someone tired? Suppose I'm running in 500 or simply 20 km per hour speed I am running. If I am tired means what happen? I will increase my speed? No, I will reduce my speed. So same thing will happen here also in alternator. If the electrical demand is more and more, what happen? The alternator will tired and it will not supply that much current. So the alternator will do what? It reduces its speed. It reduces because he is tired now. He is continuously giving and more, he will tired. So the speed will be reduced. So either at the input side or at the load side or at the transmission line itself, there is a chance of producing disturbances, and that disturbances will affect the alternator in such a manner that the rated quantities, rated voltage, rated frequency, everything will be changed. So that is called the disturbance or instability of the alternator. Is it clear? So there are three types of stability actually we have to discuss. Three types of stability generally we can have. First one is voltage stability. First one is voltage stability. Voltage stability. So normally when we are talking about the per unit quantity, the tolerance is normally plus or minus 5%. Tolerance is plus or minus 5%. That means, for example, if you are using V rated is equal to 1 per unit, then the tolerance will be, or the tolerance range will be what? 0.95 per unit to 1.05 per unit. This much variation can be acceptable in terms of voltage stability. That means if a system is operating at 230 volt, It's 5% can be increased or 5% can be decreased. That is not at all a problem. And at that time, means it is like that ball. Consider that ball example. Even if you disturb it slowly, after the disturbance over, it will come back to original position, no problem. It will not affect that much the stability of the system, but we can consider that it's not unstable. It is actually near to stability. It's okay, it's acceptable, it's fine. It's fine. Similarly, next stability is nothing but frequency stability. Frequency stability. Here also, suppose we are using 50 Hz supply, the tolerance range is nothing but, my dear, tolerance range. Or tolerance is simply, oh my god, power has gone. Oh.